All right, so in the second hour of our class, we are going to continue from where we have left. We were calculating the rate of return for cash flow structures, and we have said that if we have a single sign reversal in a cash flow diagram, then there will be a unique rate of return, which is I star, that will make the net present value exactly equal to 0. But if we have multiple sign reversals, for example, we have cash flows from time 0 to time n. If we show multiple sign reversals in this cash flow, then the net present value may be equal to 0 for several values in the interest rate. So let me explain what does that mean. What that means. So let's just say we have a cash flow diagram. We have a cash flow diagram like this. So initially we have a negative cash flow, then we have a positive cash flow, then we again have a negative cash flow here and positive here. Okay, so you see there is sign reversal at here, there is another sign reversal at here, there is another sign reversal at here. There are 3 sign reversals. So if there are 3 sign reversals in a cash flow diagram, this means there may be 3 different interest rates that may make the net present value equal to 0, which means the rate of return values may be 3 different values. Maybe. Okay, I'm not saying that exact 3 rate of return should be here, but there may be 3 up to 3 different rate of returns for a cash flow diagram like this. Why? Because in that case, the net present value plot diagram can be a decreasing first. Then because of the negative cash flows here, it can be increasing again. Then because of the positive cash flows here, it can be again negative. So in that case, you see the net present value function is going to be a function which is cutting the horizontal axis or the 0 value at 3 different points, and each of these points are going to be counted as the rate of return. So they are all going to be counted as rate of return values. Okay, all of them. So we are going to see an example about this to understand it better. So I think you should be seeing the presentation file now. Let's just say we have a cash flow diagram where in the first year we have a negative $3,000 of cash flow. Then in the end of first year, second year, third, fourth, fifth years, we have respectively 0, 6,000, 6,000, 0, and minus $10,000 of cash flow. Okay, so this is the cash flow structure given in the table format. However, these values are given in thousands of dollars. So we need to determine the net present value at different interest rates. So we are going to draw the plot diagram of the net present value. And we are going to calculate the net present value at 0 interest rates, at 5% interest rate, at 10, 20, 30, 50, and 70% interest rate values. We will calculate the net present value, and we are going to connect these dots over the plot diagram to draw the net present value as a function of the interest rate. Okay, so our objective is to find the rates of return that makes the net present value vanish. So we are going to see in how many points, how many different points this net present value function can cut the horizontal axis. Now, how many sign reversals do we have here? We have -3, and from -3, we are moving to a positive value with a single sign reversal. So between at the first 2 years, we have a single sign reversal. Then we remain at positive cash flows once again, but in the end of the 4th year, as we move to the 5th year, again there is a sign reversal. Again, we move to negative cash flows. So we have a single, 2 different sign reversals adhere from negative to positive and adhere from positive to negative. We have two sign reversals in this example, which means there may be two different rates of return for this cash flow structure. So how do we formulate the net present value? Remember, now all of these values are given in $1,000, so in the end we can multiply everything with 1,000. But let's write down the net present value by using what? So we have -3 initial payments, so the present value is going to be exactly -3. We have two $6 here at second and the third year, and we are going to use a uniform series present worth factor. So we will discount these 2 years of uniform series payment to the first year first. I% 2 is going to discount that 2 years of uniform series to the end of the first year. Then in order to calculate the present value, we also need to multiply it with a single payment present worth factor under I% interest rate for 1 year. And then we subtract 10 times single payment present worth factor, P over F. And because this is negative, it should be subtracted, and we need to discount that -10 to 5 years before with this single payment present worth factor. And the result will be multiplied with $1,000. And we are going to do this for respectively 0%. At 0%, it is very easy because what? We are simply going to sum these values at 0%. And it is going to be -1 at 0% interest rate. The net present value will be -1,000. Then it is going to increase. It is going to increase. Then it is going to decrease again. So 0%, 5%, 10, 20, 30, 50, and 70%. For all of these interest rates, we are going to calculate net present value, which is going to be starting from -$1,000, reduced to -210 at 5%. At 10, 20, 30, and 50, the net present value is going to remain as positive, but it is going to start for decreasing first, and it is going to increasing first, so it is going to decrease later. After 50% interest rate, it is going to reduce to below 0 again. Is going to be reducing below 0. And you see, according to these values, there are two rates of returns which make the net present value equal to 0. The first rate of return is between 5 and 10%, somewhere here. And the second rate of return is somewhere between 50 and 70%. In fact, I can plot these combinations, interest rate versus net present values, in this plot diagram. So at 0%, negative $1,000 of rate of return, it is increasing at 5%, at 10%, 20%, 30%, 50%, and 70%. It is reducing below 0 again. So you see, there is a certain interest rate between 5% and 10% that makes the net present value equal to 0 here. And there is another interest rate here between 0.50 and 0.70%. But I mean, figuratively, we can determine that it is somewhere between 0.50 and 0.60. But because we have only tried 0.70 here. So at this point, again, the rate of the net present value will be 0. So there are two rate of returns here. The first one is this one. The second one is this one. So we need to determine these two interest rates, which makes the net present value equal to 0. And we will call these the first rate of return, the second rate of return. Now we can apply linear interpolation between 5 and 10% here. And we can apply another linear interpolation between 50 and 70% here. And each of these rate of return values will be calculated as 6.91% and 54.67%, which means this investment, this cash flow structure has the rate of return that is both equal to 6.91% and 54.67%. Okay, so the rate of return, there are multiple rate of return for this cash flow structure. Now, we are going to talk about another topic here, which is called the payback period. Remember now, the payback period is called a secondary metric which we can use to compare alternative investments. Now, in the payback period, we are not going to use anything that we have learned so far. Remember, we have always used the time value of the money in our calculations, and we were determining the present value or the future value of these cash flows by using discounting factors, by multiplying them with the discounting factors. However, at this point, we are not going to use the time value of the money, and we are basically going to determine the payback period by the time required for an initial investment to be recovered. Okay, for example, if you make an investment that is worth $100,000 right now, and in the end of every year, if you get $20,000, in the end of every year, if you get $20,000, then in 5 years, your initial investment will be recovered by this $520,000 revenue. Okay, so your payback period in this investment will simply be equal to 5. Okay, so in 5 years, you collect $20,000, and in 5 years, the total collected amount is going to be the initial investment amount, which means the initial investment will be recovered in 5 years. Okay, but as you can see, I have not used at any part of this calculation any interest rate. So I am basically assuming the interest rate to be equal to 0. So what is the payback period? Payback period is basically this. So we are summing the future cash flows from the first period to the payback period. When the sum of the future cash flows exactly become equal to the absolute value of the initial cash flow, then that number of periods is the payback period. So in how many years we are recovering the initial payment, that is the payback period. Now, if the future cash flows form a uniform series, annual series, then all you need to do to calculate the payback period is to divide the initial investment's absolute value to the payment amounts. I mean, for example, I have computed that my payback period in the previous example was 5 years. I compute that? I have divided $100,000 to $20,000 of annual payments, and that makes 5 years to cover all of the money. But if the initial investment is not divisible, to the annual payment, for example, instead of $20,000, let's just say $30,000. When you divide $100,000 to $30,000, you are going to get 3.33. 3.33. That is going to be your payback period anyway. So the payback period is not necessarily an integer value. It may not be an integer value as well. So it can be any ratio as well. So let us compute the payback period in this example. So we have the initial cash flow, which is minus $50,000 in this investment. And then for the following 5 years, we have 10, 12, 15, 18, and $20,000 of future revenues in the end of each year, respectively. So the question is, what is the payback period in this example? Now, let's see. So we need to see in how many years I will cover this minus 50. Now, I'm going to, assuming that interest rate is 0, I am $10 in the end of 1 year, and my total will be minus 40 here. I will get additional 12 in the second year, and my total, the cumulative cash flow, will be equal to what? Minus $28. Minus 28. So $22 will be recovered, $28 will be remaining. I will get a $15 in the end of the third year, and my cumulative cash flow will be minus $13,000 in the end of the third year. Still the initial investment has not recovered yet. There's still a $13,000 of initial investment that is not recovered. And how did I calculate that minus $13,000? By calculating the accumulated cash flow up to the third year. But if you include the fourth year, you will realize that you are going to go to the accumulated cash flow will be equal to $5,000, which means by the end of the fourth year, you will be recovering your initial investment, plus you will be additionally having a $5,000 of profit. So the payback period where you recover your initial payment should be calculated as a value somewhere between 3 and 4 years. Not exactly 3 or not exactly 4. Okay? So how do we do that? We are going to apply a linear interpolation again. So we will say that so we are going to have a plot diagram like this. In 3 years, the accumulated cash flow, which is ACF, accumulated cash flow, with initial amount and the revenues, future revenues, is going to be minus 13,000. I am not writing the thousands here. At the fourth year, so let's make this equal to time here, or years, maybe years we should say. So at the fourth year, it is going to be positive $5,000. Okay, at the third year and at the fourth year. So there is a point between 3 and 4, which is going to be making that accumulated cash flow equal to 0. So we are assuming a linear interpolation between 3 and 4. And what do we do? At 3 years, the accumulated cash flow is 13. At 4 years, the accumulated cash flow is 5. So what I am going to do is to apply a linear interpolation between these two. I will multiply 3 with 5 and 4 with 13, and the summation will be divided to 18, maybe in $1,000. I mean, you can also multiply them with $1,000, but linear interpolation idea can be applied here, and the payback period will be 3.72 years in this example. So approximately in 3.72 years, we can recover our initial investment, assuming that the interest rate is equal to 0. So how can we compare the payback period with the rate of return? Which one should we use? Now, the payback period ignores the time value of the money. So it assumes that there is not an interest rate. We have 0 interest rate. The payback period should not be used in place of the net present value or the return method. So when you are comparing alternative investments, always look at their net present value or the rate of return. Okay, always. However, when the results that you get from the net present value or the rate of return methods are similar, when they are similar, in that case, you can use the payback period methodology as a secondary measure, secondary analysis to make a final decision. Okay, so when we have two investments with the same rate of return value, in that case, we can compare the alternative investments by looking at the payback period. If the payback period is shorter, if it is less, then that investment should be preferable, because the earlier you get the money is better. Okay, earlier you get the cash is always better. Now, let us determine the payback period and the net present value for each proposal here. So we have 3 proposals. In proposal A, we are going to pay an initial amount of $75,000 at time 0, and for the following 4 years, we will be paid $25,000. So if we assume the interest rate is 0, we will just make a $25,000 profit in this investment. In proposal B, again, we are going to pay initially $75,000, but then we will be repaid $20,000 in the end of the first year. In the end of the second, third, and fourth year, we will be paid $25,000, $30,000, and $35,000, which will be in the form of a gradient series, right? So with a base amount of $20,000 and a gradient amount of $5,000, our payments will be increasing linearly. And in the third case, we will be initially investing $75,000 right now, and in 4 years we are not going to get anything. In the end of the fourth year, we will be collecting a $130,000 of lump sum. So, which proposal is the best? Which one would you prefer? If you assume that the interest rate is 10% per year. So when you are calculating the net present value of each of these proposals, you will be assuming an interest rate of 10% according to this question. Under a 10% interest rate, which proposal is better? We need to compare. Okay. And then we are going to check their payback periods as now. The net present value for proposal A, proposal B, and proposal C is respectively $4,248, $10,289, and $13,792. Okay, under 10%, the present values are calculated. In the first proposal, we use the single uniform series present worth factor to discount the uniform series. Here we use gradient series and also uniform series present worth factor to calculate the present value. And here we use the single payment present worth factor to determine the present value. And the largest net present value is obtained in C than B, but for proposal A, it is a lot less comparatively to proposal B and proposal C. So proposal B and proposal C are preferable when you need to check the net present value. And there is a difference between B and C as well. Now, the payback periods, if we check the payback periods, remember now, for a uniform series of future payments, you basically divide the initial investment in absolute value to the installment size. So when you divide 75 to 25, you get 3. The payback period for the first investment is 3. The payback for second proposal is, we need to check the cumulative cash flows. So we have minus 75 in the first year, in the time 0. In the end of the first year, 20,000 of this amount will be recovered, but there will still be remaining 55,000. And then we have 25 more, which means the recovered amount will be increasing to $45,000. And exactly at the third year, all of the 75,000 will be covered exactly at the third year. Okay, so the payback period of the second proposal is also 3 years. But how about the third year? For the third year, you are going to apply a linear interpolation between the cumulative accumulated cash flows. So the accumulated cash flow at times is minus 75. At time 1, it is still minus 75. At time 2, it is still minus 75. At time 3, it is still minus 75 because we do not have any revenues in the end of the first 3 years. So the accumulated cash flow until the end of third year will still be minus 75. Therefore, when we are going to apply a linear interpolation, we are going to do what? We are going to apply that linear interpolation between 3 and 4 years again. At 3 years, the payback, the accumulated cash flow, ACF, is going to be minus 75. And at 4 years, it is going to be 130. Okay, and we are going to apply a linear interpolation between 3 and 4 years here, and as a result, I'm sorry, not 135. So this value is incorrect. Sorry. So from minus 75, we get 130. So the accumulated cash flow is going to be 55. I am sorry. So with minus 75, if you add 130, it is going to be 55. So here is 3.58. 3.58. The payback period is going to be linearly interpolated to 3.58. So we are just going to show that the payback period is 3.58. Now you see proposal A has a net present value, which is a lot less than proposal B and C. And if you check the payback periods, they are 3 years. If we have two exact payback periods of 3 years here, of course, I would always choose proposal B on proposal A. So proposal B is definitely better than proposal A. So what I need to compare proposal B with proposal C. Okay. Now, proposal C has the highest net present value. Therefore, it seems better than proposal B. However, its payback period is a little larger than the payback period of B. Okay, so you get much more money, but you get that money later. Okay, so which one you should select? I mean, I always choose the net present value, largest net present value. I mean, the difference between the net present value of this amount and this amount is a lot large. Okay, so there is almost a 33% increase in the net present value of proposal C compared to proposal B. However, the payback period is also a secondary measure that we should take in account. When I check the payback periods, I mean, it is just only half a year larger than the payback period of B. So I would say that I would wait for an additional half a year to get this extra 30% net present worth. I think proposal C should be selected. However, if you are experiencing a cash problem, okay, if you are experiencing a cash flow problem, and if you want to get your cash liquid amount of money as soon as possible back, these kind of investors may think about investing in property as well. Okay, maybe you are cash poor, maybe you need cash as soon as possible because of your future investment plans. Maybe you would choose proposal B, even though it brings a less net present value than C, because it returns the money at an earlier time. Okay, maybe in the end of the third year, you will find an interesting investment opportunity, but if you wait for 3.58 years, you are going to lose that interesting investment opportunity. Sometimes, even though the money is less, sometimes getting paid earlier is a better idea. Okay. Now let's look about the benefit cost ratio. This is the final topic that we are going to cover, but I'm just going to do that after a break of 10 minutes. After 10 minutes, let's meet here and again continue from where we have left.